All right, hello. In this video, I'm going to talk about the Lumos architecture, as well as the GitHub repo layout, where everything is located, and some tools that are helpful, generally helpful for administrating the repo as well as testing the Lumos project. So, a lot to cover. So let me go ahead and get started and just show you the layout of the project here. The Lumos Trade node package is really the core of the project. This is where all of the data logic is, all the trading logic is, all of the broker logic is. Everything that's kind of core to the processing happens inside Lumos Trade. I'm going to walk through some of this configuration in a second. This is included by one of three areas. The Lumos CLI is a CLI tool that just imports the Lumos Trade project, and you can run a command line interface in there to just do tests. It's pretty basic right now. I was using it for ad hoc command line testing without going through the web app, as well as kind of a way to keep me honest that I was maintaining a one-way dependency to Lumos Trade and not having it get polluted by other projects. Lumos app is the web app, so all the UI components are in there, and I'll talk about that in a second. And then Lumos AI has all of the agent and tool code, which may or may not depend on Lumos Trade as well. It does not depend on Lumos app. So let me talk about Lumos Trade in a little bit more detail. I think one of the most interesting aspects of it is the broker interface. So if you look in the interfaces folder here, these are all the constructs I use, and it's a Node.js package, and it's using TypeScript, so that I can benefit from strongly typed strongly typed JavaScript, because the runtime aspects of JavaScript sometimes drive me a little nuts. Let me kill this. And having strongly typed, just saves me from some errors along the way, even though there are some, weirdisms with TypeScript as well. But anyways, if you look in here, there is a class called Broker Client. And this is basically the interface that you have to implement to support a new broker. So right now, we support E-Trade and Charles Schwab. If you wanted to add a new broker like Fidelity or really any of them at this point, you would basically just have to implement these functions and return these broker agnostic types here. And you can put no ops for some of them too if you don't want to support that. If you go into the brokers folder here, you can see, for example, I have E-Trade, Schwab, and the simulator, which I talked about in the demo. The simulator just implements these functions and returns mock values, which was very useful for testing as well as generating the demo account. So for example, ET client is not ET the extraterrestrial, but at E-Trade, and it implements the broker client, and it has basically all the functions to implement the various aspects of that. I use a kind of a standard pattern here for both E-Trade and Schwab, where I have this response manager that basically matches the responses returned by the API into the appropriate types. So that kind of makes processing a little easier as well. I will, if there's interest in providing additional brokers down the road, I will probably make another video on that, because that's kind of an important aspect of it. All the broker config is also in these config files. So I use a node config package that I imported. These are just designed to be semi-static in nature, right? Like mostly URLs in here. These are not where secrets go. These are more for the configuration of the brokers themselves, and maybe any just general purpose config. You do have the ability to override these on per environment if you need to. In an earlier version of Lumos, I was using this quite heavily, and then I moved a lot of this into the secrets system and the environment variable config. So I don't use that as much now, and I use it mostly just for static URLs. You could have different, like E-Trade has a different set of URLs for their sandbox environment versus their production environment. I found that generally wasn't too useful for me because most of the operations I was doing was read-only anyways, just pulling information out of it, and using their mock data in their sandbox environment was actually kind of more trouble than it was worth, and it was just easier to test against some of the live data. So I just went ahead and just put the production URLs in here. But if you want to change that, you can override these on a per environment basis as well. All right, so let's talk about the database. So all the data access is in this database section here. You can see there's a dump of the entire database here, which was used as from the install process to create the schema. And then all the data, all the queries basically are in here for the Lumos system. It's, as a funny aside, originally I had created some stored procedures to handle a lot of this, because I was kind of classically trained on writing SQL to generally put complex queries and stored procedures. I was actually finding with using the AI tools that was turning out to be more trouble than it was worth, since the AI tools couldn't really easily modify the stored procedures, but they could very easily modify these inline SQL statements here. And since this isn't like a super high scale concurrent system where every millisecond matters for the queries, it was kind of okay to do this, and I found that the AI code just naturally protected against some of the common security holes that you get in inline SQL, like SQL injection and scripting attacks. I found that generally it did a pretty good job of protecting against those. So these are all structured in here, and then as I needed to make changes to the query, since it's directly in the code, the model would just go in and update the query and make some pretty darn good changes here. There's a base class here that implements all of the actual connectivity to the database in one place. You can see it pulls these config entries here, and I'll talk about those config entries in a second. Actually, let's talk about it right now. The environment is defined in these environment variables. So when you run through the installer, it will set up, in a per environment basis, this environment file that has basically all of these config entries that are passed either when you run it for debugging or when you deploy it. It has all the Google Cloud resources and any parameters about the runtime that you might need, and that's pulled by the app. So that controls where the database is, where the what service accounts are used, URLs for the projects and so forth. So when the build runs, it actually expands these out to these expanded files. So this is kind of a helpful reference if you ever forget where particular URLs are, for example. So this is all set up by the installer, but if you want to go in and tweak things, you can go and do that in these environment files as well. All right, let's talk about tests. This in the test directory. So Lumos Trade uses Jest for testing. And I was able to create, and every one of these tests was generated by AI. I reviewed them and I tested them to make sure that they're getting the results that they should. But there's hundreds. I think there's 250, 300 tests in here. This is where AI really shined. I found the models did an incredibly capable job of specking out all the different parameters. When I had to implement a new function, it would do a really credible job of anticipating all the different use cases and creating very good unit tests for all of that. It was very helpful. With the trading algorithms, there's a lot of variables that spidered out, right? Inevitably, I wanted to test if a trade was a win or a loss, and if it was a long trade or a short trade, right? So that's 4 variants of every scenario that I want to test, which just kind of spidered out to hundreds of different options and variables that needed to be done, and it just did a great job of mocking these all out. If it didn't, if I was writing these by hand, I'd probably just test a few of the fields to make sure they were right. But since the automation was creating it all, I could have it test all of the fields, and make sure every step of the way that they were properly equated out. Let me go and just run these as well. So if you want to run them, you can go into the launch config I'm using Visual Studio Code here. I have it all configured in the launch config, so I can just run test Lumos Trade here. It'll do a compile, and then it'll run it, and it'll run all the tests in parallel. And you can see it takes a little bit of time because there's so many tests here. I don't do it on every build because it takes so much time, but if I do a major update, I'll run them through. That's 271 tests, just like that. And if I needed to refactor or add new tests, it was just a breeze using AI to do that. So that was just an incredible power use case for that. Let's see if there's anything else in Lumos Trade. I think that's most of it. Here's TypeScript config. Like I said, everything's in TypeScript here. You can run through some of these other classes at your leisure and ask questions if you may. Lumos app is the web interface for it. So it follows a model view controller architecture. It uses Express.js to handle all the views. The views are actually pretty lightweight. You can see these EJS files everywhere. Oops. I got some leftovers from leftover approvals here. But, pretty lightweight view files. Most of the logic's actually client-side in JavaScript that, because I have a lot of, dynamically generated content both for the tables and the charts. But the model view controller architecture here, you can see, all the styling is in here. You can see it uses Bootstrap for a lot of the, pretty formatting, high charts, font awesome, just some of the standard libraries, for a lot of these different constructs. Anything in Lumos app is just dedicated to the visualization of the data itself. If it's core logic that I want to reuse in other places, it goes into Lumos Trade. Controllers are pretty lightweight as well. And the models did a pretty credible job. The Copilot instructions, the Markdown had information about the layout here. And then whenever I asked it to add a new page, it would automatically detect based on the existing patterns that it needed to create a model, a view, a controller, client-side JavaScript or request handler, and use the existing master page, right? So it was really easy. Whenever I wanted to create a new page, it was just really a prompt, and it would create all the right files and places that needed to be, and I was able to run off to the races. So I was pretty pleased with how that would work. I don't think there's too much we need to talk about here. Oh, if there were any database queries specific to the UI itself, I put that in the app data access class, which implements the data access base, which Lumos Trade did as well. So I tried to have a kind of a clear separation of concerns. This would only be for your database queries that would power the views themselves. Anything that's kind of core to the processing of the trade logic was in Lumos Trade. And I put some instructions in the Copilot instructions to keep that separation of concerns going. All right, let's talk about Lumos AI. This is where all the agent and tool infrastructure is in place. So let's start with the agents. You can see they're listed under here. There's two. Lumos Chat Agent, which most of this code is scaffolding. Agent PY, this is Python code, has basically all the prompt instructions for this. You can actually go into Vertex AI into the agent designer, and it will generate a lot of this code for you. And then AI generated some of the scaffolding on top of that for me. So I have the prompt for it. You're providing tools and information for a stock portfolio, instructions, and again, like I mentioned in the AI video, if you haven't watched that, watch that please before this. I was using prompts here with Copilot to actually create these prompts, and it did a much better job prompting than I would have done. It took my kind of ill-formed, loose constructs and put some pretty precise and accurate instructions into the prompts here. So that's all in there. And then you can list out the list of tools. So these are the MCP tools that this agent will include for its use. Two that I've created, Lumos DB and Lumos Trade. And then off the shelf, Google Search and URL Context Agent tool, which is you can drop a URL in there and it will pull in the contents of that URL and analyze it and include it in the response. So that was pretty powerful. I know there's a whole garden of models that you can include in here as well. I haven't played around with those too much, but that is how Lumos Chat Agent works. Lumos Conjure Agent, very similar. Similar construct. This is also, it follows kind of the same pattern. Here's the prompt instructions. As I mentioned in the AI video, one of the fundamental differences between the Conjure agent and the Chat agent is Conjure returns highly structured responses. So you see here it says strict response, always return a JSON object. This is critical, you only return JSON, and it gives kind of structure of how to do that in here. Again, the Copilot prompts help me make this. The reason I want it structured is because I then feed this into high charts. I have an adapter layer in the view that will actually take that JSON format into high charts or into a table and just generate it into a visualization. So I'm not looking for text responses, although you can still have messages returned here as well. And it just kind of drops it in here, and there's some guidance in here about the data types and when to use different kinds of charts and the different series formatting for each of those. It talks about some of the tools. So, if it's using Lumos, this actually, let's see here. This only uses Lumos DB tool, which is the MCP toolbox for databases, which is just basically database queries on my Lumos database. This gives just some guidance on the different tools available by that, and then how to format the responses based on that. So again, just a different way of coding, right? Like we're not writing curly braces, we're writing English here. That took definitely some getting used to for me, and it's a non-deterministic state. So testing became a little bit of a challenge on that, and I think there maybe some more I can learn about that. Maybe some opportunities in the industry to find better ways of testing non-deterministic responses, right? Like this. For me, it was that's not something I could automate with just tests, right? I had to just do it manually. So I'm kind of curious to learn more about best practices of that in the future. Okay, let's keep going. Let's talk about the tools. So MCP tools are imported by the agents. I have a cloud run service running. If you watch the install video, it talks about I have a cloud run service that's running the agents. It runs them both in the same service. I have one running for Lumos DB and one running for Lumos Trade tool as well. Lumos DB is very lightweight. It's basically takes Google's MCP toolbox, and you just take a Docker image and you feed in this tools.yaml file, and it has all your SQL connection information from environment variables, a prompt around what you want to return, and then just different tools. So, for example, the search trades, you might have remembered it from the prompt in the agent. That exposes what that tool does, what parameters it takes, what responses it gets, and what the SQL statement is to run. And you see other trade history, when to run it, parameters, and so forth. I think I've mentioned this in another video, but some of the SQL queries here could get kind of complex, and I really enjoyed watching the AI work on these. I feel like I'm a credible SQL developer, but not like an expert, and it's really hard to debug SQL sometimes. But I found with the AI tools, it could generate some pretty complex SQL statements with relative ease, and then if I encountered errors, rather than pulling my hair out trying to debug them, I would just copy paste the error in there, and it would debug it and correct it, and I would just continue to iterate until I got it working, and that's really good. And since this is a single tenant self-hosted solution, I didn't have to be quite as concerned about data leakage across tenant boundaries, so that gave me a little more safety here. But still, I think the models did a pretty good job of using best practices and not exposing yourself to SQL injection and other security holes here. All right, and Lumos Trade tool is an agent I wrote. This is a Node project. This actually just imports the Lumos Trade core library that I talked about earlier and exposes some operations that you can do. So, for example, this register tools function right here, you can create all the different tools that you want to expose by this. I just exposed two: get quotes and refresh brokers. Get quotes just basically calls into the here it is, E-Trade or Schwab's client, and calls get quotes, which is exposed from the Lumos Trade library. So that's basically calling the E-Trade API, getting quotes real time back, and then returning it in the results. So mostly just a proof of concept, just to show that I could call business logic from a prompt and expand it out as needed. So I thought that was pretty helpful. All right, let's see if there's anything else to talk about the overall architecture. I think those are the highlights there. I wanted to shift gears and talk about the command line infrastructure. So if you go to the root and type Lumos, there's a shell script that has a bunch of tools available. I use these myself for developing the project and administrating the project, and I thought they could be quite helpful for you as well. Let me look at my notes, make sure I didn't miss anything. No, I think I didn't. Okay, so let me do a quick run through of these. I'm not going to go in detail all of them, but if you run, this is the command like Lumos action and then the target, right? If you run Lumos off, it will run the Google Cloud authentication process. So it uses gCloud's command line interface. So you do have to be logged in, ideally on your owner account or something that has significant permissions to create all of the resources. And it will do a login for you on that if you're not already logged in. So that's important to run for all these different tools. If you are just using the install, then you probably don't need to rebuild it. But if you want to develop on the project, you can run the build command, and you can do a complete fresh build. I found the watch kind of useful. So like if you want to do build watch, it will now go into watch mode, and whenever you make changes to TypeScript files, it will automatically pick up those changes, recompile them, and report errors for you. So that's pretty helpful as you're doing that. And then you can do a deploy as well. So if you want to push out to production, or I'm sorry, out to Google Cloud Run, the various services in there, you can build them all sequentially. You can build them all in parallel, which I highly recommend doing. It's significantly faster than all. You can probably save like 70% of the time by doing that. Or you can build and deploy just specific services as well in here. The environments, so I think I mentioned this in this installer, but if you want to create a new environment, so for example, let's do the Lumos environment list. You can see these are my current environments. Let's say I wanted to create a new one called, I don't know, Mark's environment. And then it will automatically create that, and you can select one of the GCP projects to link to it. Let's say this one. And it will configure. If you go into now this config file here, you will see it just created Mark's environment. And it has these values are automatically plugged in for you. So that's kind of useful if you want to have a different environment to do different work on, for example. And you can deploy, ideally you run this through the installer, so because you have to have the resources on GCP to match all of this. But this is helpful if you're just kind of configuring your own system. Okay, let's go back here. Install, there's a whole video on this, so walk through that video. This is what you do the first time you set this up. You probably won't need to use it after that, although the install is rerunnable. So maybe if something gets really messed up on the back end, you could rerun this again to try to repair things. If it gets really messed up, you might have to just kill your project and start anew, but hopefully this will get things in the right spot. Lumos Run is useful for local debugging. So for example, if I wanted to debug the agents, like change the prompts and see how they come back, I can do Lumos Run agents. I didn't put the right target. Lumos agents. So for example, the agents are now running on this local port. I can configure, if I go into my config file, for example, I can configure my agent's URL to be, where is it? Right here. I could change this to be the localhost address, for example, and then I could run it in my local debugger and it would connect to the local instance instead. So this is very useful when you're doing prompt development, because you don't want to keep deploying to production every time you change your prompts, because that is very slow. Okay, let's go back here. I know the video is running a little long. Secrets, we talked about this in the installer. So if all passwords, users, passwords, access keys, tokens, API keys, that sort of thing are in the secrets manager. You can download them at any time using the download. So let's set my environment back to, I don't want to show my secrets, but it'll download them. It will put them in this config directory here, following the secrets template format. And you can pull your information from that and then just delete it when you're done, or change it and upload it again if you want. Service accounts, if you need to, you probably won't need to do this, the installer does this, but if you need to update your service accounts or verify permissions on that, you can run update and it will just resync the service accounts and make sure they have the proper permissions to run. So remember, everything's running on least privilege. The different cloud runs all run under different service accounts. So the Lumos app, the website, has one service account. The agents run on a different service account, and the tools run on a different service account. And they only can do, they only have permission to do what the service account can do. So I tried to button that down as tight as I can. And then that also, like if you go into the, let's go into the cloud. If you look at the cloud run services, for example, you can see that except for the website, they all require authentication. So basically only the service accounts that are created can access these endpoints, except for Lumos app, which has the cookie-based user authentication when you log in, like a traditional web app. Okay, and then last but not least, Lumos SQL. So this might be useful if you're just using the project, you probably won't need this, but if you're developing on the project, you type Lumos SQL and it will actually generate, let's change the environment. Little trick here, if you just put the environment after Lumos, it'll change it for you. So now we're in demo. We're in demo environment. Now it sets up a proxy listening on that port right now, localhost. If you go into your favorite SQL tool, I've been using SQL Table Plus. You can see here on the connection information, localhost, that port. This is the user and password that was created during the install process. Hopefully you wrote down that info. If you didn't, just download it from your secrets. And then connect. And then here's those accounts that we showed in the demo, for example. So it's all right here. And here's the brokers and the orders and trades, and it's all there. So if you need to just kind of see how it works under the hood or change anything, it's all in SQL right there. All right, did I miss anything? I'm sure I did, but I think I've talked enough. If there are any questions on the project, I'm happy to answer them. If there is, I'm sure this will evolve over time, and some of this will become obsolete in the future. If it drifts too far, I'll create a new project for that as well. Or I'm sorry, a new video for that. It would be nice to have a nice architecture diagram. I'm hoping that I can actually take use Gemini, feed this video into Gemini, and have it generate some content that I'll put on the GitHub repo, and maybe can create some architecture diagrams. We'll see. Anyways, I hope that was helpful. I hope you enjoy this, and thanks for looking at the project.